Hi everyone. Now we'll move on to a topic of salts. Having learnt about acids and bases and indicators earlier videos, now we go on to salts. What are salts? It's a product of neutralization. And how do we get this? When you take it, this salt will be made. So it's a product of neutralization. What is neutralization? When an acid and a base reacts. So what happens there? There will be a partial or complete replacement of the hydrogen ion of the acid. Okay, so that's the next point. And when this happens, there is always a positive ion in a salt. But this positive ion will be something other than hydrogen. So excluding hydrogen, there will be a cation. Then there would be a negative ion other than hydroxyl ion. Okay, so these are the things that would form part of the definition of the salts. So based on the partial replacement or complete replacement, we can divide these salts into three types. One is acid salt and the other one is normal salt, and we also have basic salt. So these are the three types of simple salts that we are going to see right now. Okay, when we come to acid salt, this will happen by partial replacement of hydrogen ions. That means, when does it not replace completely? When there is insufficient base. The base is not enough. That is when there will be a partial replacement. For example, if we take sulfuric acid, dilute sulfuric acid, this reacts with sodium hydroxide, which is right now only one molecule. Then it could only form sodium bisulfate and one molecule of water. Now this results in an acid salt. This is due to partial replacement of the hydrogen. Both are not replaced. See, there are two hydrogen atoms, only one is replaced. Okay. In that case, this will exhibit acidic properties. All acid salts will exhibit acidic properties as long as hydrogen ion is present in them. Now we go to normal salt. Now this will be as a product or result of complete replacement of hydrogen ions. When does that happen? When there is sufficient amount of base. Okay, for example, if the same sulfuric acid dilute reacts with enough amount of sodium hydroxide, that gives you sodium sulfate plus water. Now there is no hydrogen here, therefore this is a normal salt. So if there is no hydrogen, then there are no acidic properties. Okay. Alright, now going to the basic salt. This is partial replacement of hydroxyl ions. Okay, this is due to partial replacement of hydroxyl ions, OH ions. When does that happen? Here there is insufficient base, but here there is insufficient acid. So it has not been completely neutralized. So what these basic salts would have is, it would have a metallic ion. okay, plus there will be one hydroxyl ion also, plus a non-metallic ion or radical. Radical we call when it is made of a group of atoms. For example, if we have copper and here you have one hydroxyl and then there is a chloride, copper hydroxychloride. Okay, so this we write as copper hydroxychloride. Similarly, copper hydroxynitrate. These are basic salts. Next we move on to the solubility of salts. Why we need to know this is because before we go into the preparation, we need to know which is soluble, which is not soluble, and that comes with a beautiful simple diagram as this. Okay. Now all the soluble salts come in this circle, which means all salts of sodium, potassium and ammonium are soluble. In whatever form you take, they are soluble. But all other carbonates are insoluble. In chlorides, all chlorides are soluble except silver chloride and lead chloride. All the nitrates are soluble. So this is where you need to note down one point. Lead nitrate is one lead salt that is soluble. All other lead salts are insoluble, but lead nitrate is soluble. Of course, lead chloride is soluble in hot water, but again insoluble in cold water. Okay, so lead nitrate also, barium nitrate, all nitrates are soluble. When you come to sulfates, these are the three sulfates which are insoluble, but all other sulfates are soluble. So this we definitely need to know so that it will help us when we prepare the salts. Now we move on to the preparation of salts. When you go to preparation of salts, there are different methods used for different things. Just like at home, mummy uses different methods to prepare different things. We need to have different methods here. The first method is direct combination. Combination or synthesis. So what does it mean? You are combining two substances and bringing a new one. Okay, this usually happens with a metal plus a non-metal, and the salts that are prepared in this way are soluble chlorides. Okay, and also some insoluble sulfides are also prepared. So for example, if we take iron, this can is a metal that reacts with chlorine to give iron 3 chloride. Okay, 2 here, 3 and 2. This is a direct combination. This is a soluble chloride. Okay, when you come to insoluble sulfides, iron can combine with sulfur to give iron sulfide. Lead can combine with sulfur to give lead sulfide. So this is direct combination. Now we move on to the second method, that is displacement. So in displacement, what happens? We have active metals, meaning metals above hydrogen in the reactivity series, like say we can take zinc or magnesium or iron. Okay, then this reacts with dilute acid. For example, if we are taking zinc plus say dilute HCl, this would give you zinc chloride plus hydrogen. Magnesium can combine with sulfuric acid, again dilute, to give magnesium sulfate and hydrogen. What's the displacement happening? It displaces the hydrogen ion and then you get hydrogen that's being liberated. The one important thing in this displacement is that it is often accompanied by brisk effervescence. And when you have this brisk effervescence happening, that means reaction is going on. When the effervescence stops, that's the end of this reaction displacement. This we will see with a simple thing of adding zinc and dilute acid. Now when we take dilute hydrochloric acid, okay, and if we add some zinc powder to it, we could add zinc granules or zinc powder as per the availability. So when we add this, it starts reacting and you can see the brisk effervescence happening. That's where hydrogen is evolved and the salt that is formed here is zinc chloride. Okay, you can see fumes of hydrogen. This is brisk effervescence. Slowly this effervescence would stop and the reaction stops. Next we move on to the next method, preparation by double decomposition. Decomposition is to break down. So double is to break down two compounds. Okay, so when we have two soluble salts, they act together to give one soluble salt and one insoluble salt, which forms a precipitate. Okay, so this precipitate is taken, filtered, and the soluble salt is retrieved from the dissolved portion. Okay, so this is how salt is prepared. For example, we can prepare lead chloride using this method. And remember, the only soluble lead salt is lead nitrate. So we take lead nitrate, in which case if we need lead chloride, we need a chloride salt. So we would take sodium chloride here to give you lead chloride and sodium nitrate. Okay, so this is a precipitate. When you denote it by an arrow mark, it is a precipitate. So this is the precipitate here. Similarly, we can also prepare calcium carbonate. How do you prepare this? Calcium chloride is soluble. Sodium carbonate, all carbonates of sodium and potassium are soluble. Again, you break them down like this. So you get calcium carbonate and sodium chloride. This is soluble, this is insoluble precipitate. So we can prepare lead sulfate like this. Okay, so again we have to take lead nitrate because that's the only soluble lead salt, and to this we can add sodium sulfate or ammonium sulfate. Again break into two, so you get lead sulfate plus sodium nitrate. So this is how you get these precipitations. One of the things we can see is we can add lead nitrate and sodium chloride and we'll see how we get lead chloride. When we do this lead chloride, one important thing we should remember about lead chloride is that it is soluble in hot water, insoluble in cold water. Okay, that we should remember. But lead nitrate is soluble in hot and cold water. So we take lead nitrate solution. See, it is soluble. Okay. Sodium chloride, again solution which is soluble. Now adding these two together, you get a precipitate of lead chloride, and as this precipitate settles down, the lead chloride will settle down as a precipitate. You can see the precipitate forming. Now slowly the lead chloride settles down. Okay, so this is the reaction that's happening here, and sodium nitrate will be in the upper part. So when we filter it, we get sodium nitrate from this part and lead chloride from this part. So this is called as a precipitate. Heavy particles settling down insoluble in water is a precipitate. The next method is neutralization. This is used to prepare soluble salts okay, but what we are going to use is insoluble base. So we take an insoluble base, add dilute acid to it to get soluble salt and water. It's basically neutralization. So the salts prepared in this way are copper sulfate, copper nitrate, lead nitrate, etc. So we will see copper sulfate and lead nitrate. We can prepare it with copper oxide or copper hydroxide. Both are insoluble. Similarly, lead oxide or lead hydroxide. Okay. Now if copper sulfate has to be prepared, the acid that we need would be dilute sulfuric acid. Okay, so it neutralizes to give you copper sulfate plus water. Okay, when you come to lead oxide, what we are going to prepare is lead nitrate. Therefore, the acid that we use would be dilute nitric acid. So that gives you lead nitrate plus water. Okay. Similarly, here also dilute nitric acid with lead hydroxide also gives you lead nitrate, which is a soluble salt, plus water. So this is basically a neutralization reaction that's happening. The next method also involves neutralization but with titration. This method is called titration, and this makes use of dilute acid plus an alkali to give you a soluble salt plus water. So we can prepare sodium chloride. Okay, if we take dilute hydrochloric acid and sodium hydroxide, this gives you sodium chloride and water. This is as simple as that. Then we could also prepare with sulfuric acid. If we add alkali, we would get sodium sulfate and water. So this is also possible. Then we could prepare with dilute acid and ammonium hydroxide. When it reacts, you get ammonium chloride plus water. Okay, in everything the base and acid split up like this, and the water molecule is formed and the rest of this forms the salt. Now how to find this is by way of titration, where we take this is called the burette, we fill it with acid, and this is called the conical flask. Now I have pipetted out some of the base into this, okay, like this, and I have pipetted it out into this. This is called as a pipette. Basically we try to find out the strength or how much of acid is required to neutralize, but here we are using it for the preparation, and to this we add 1 drop of phenolphthalein. So the color changes, and now when acid is added to this dropwise, there is one point when the color disappears. So we have to be really slow. It's still slightly pink, and now it has disappeared. This is called as the end point of the reaction, end point, which means the reaction is over. Okay, which also means that the base is neutralized by the acid and what is present is the salt in water. So this we take and saturate it and crystallize it, we get these salts. So this is how neutralization happens with titration. So with this we finish this chapter. I hope you enjoyed this chapter.